All right, let's dive into some Java. We're taking a deep dive into the world of persistence today.
Sounds good.
You sent in an interesting PDF titled Lesson 305.4, Object-Relational-Mapping, Java Persistence API, and Hibernate.pdf.
Okay.
And it looks like it's going to be fun to break this down.
Yeah.
So we're talking about how to bridge the gap between those, nicely organized Java objects and those sprawling relational databases we all have to deal with.
Right.
By the end of this, you'll have a good handle on ORM, JPA, and Hibernate.
It's going to be great.
Oh, yeah, Hibernate. That's the Rockstar implementation.
Oh, for sure. And what's really fascinating to me is just how these technologies completely changed how we write Java code.
In what way?
Well, just imagine how painful it would be to have to deal with raw SQL every single time you needed to interact with your database.
Yeah, that sounds like a major headache.
It really does.
So, okay, let's start with the fundamental problem here. This clash between the object-oriented world of Java, and then you have that tables and column structure in relational databases.
Yeah, right.
The PDF calls it the impedance mismatch.
Yeah.
What does that actually mean for someone like me who writes Java code?
Well, think of it this way. In Java, we deal with objects, right? With their properties and behaviors. But in a database, all that data is stored in these tables with rows and columns. And trying to make those two things fit together, it's like trying to fit a square peg in a round hole.
I get it, yeah.
It doesn't work very well.
It's a mismatch.
Totally.
So that's where ORM comes in, or object-relational-mapping, right? To kind of smooth things over.
Yeah, you got it.
It's
like a bridge.
Okay.
It lets your Java code interact with the database as if it were just dealing with plain Java objects.
Oh, okay.
It just takes care of all that messy SQL behind the scenes.
So I don't have to write all that code myself.
Yeah, exactly. You don't have to write those complex queries for every little thing you want to do.
That's nice.
Right. Makes life much easier.
Yeah.
It's like ORM is this translator whispering the right SQL phrases to the database while you can just keep speaking Java.
I like that analogy. So I can speak fluent Java to my application, and ORM translates that for the database.
That's a really good way to put it.
Cool. So this brings us to JPA, the Java Persistence API.
Yes.
I see that everywhere, like all the time.
For sure.
But it's actually a spec, not a specific tool. Is that right?
That is absolutely right, yeah.
So how does that work?
Well, you can think of JPA like a blueprint for building a house, It defines all those standards and guidelines for how ORM should work in the Java world.
Okay.
But you still need someone to actually build that house, right?
Right.
So you need a construction crew.
Like a contractor.
Exactly. And that's where implementations like Hibernate or Eclipse Link come in.
Okay, so JPA is the blueprint. And Hibernate's like the contractor who knows how to build the house.
That's a really good way to think about it.
All right, so I'm starting to see the difference there.
Yeah.
JPA is like making sure that no matter which contractor I choose, everyone's speaking the same language.
Exactly. It's a common language.
A good thing, right?
For sure, yeah.
I'm not locked into a specific vendor. I can switch things up if I need to.
Absolutely. It gives you flexibility and choice.
Gotcha. And another thing that's cool about JPA is that it really focuses on working with objects, right?
Yes, that's a key aspect of it.
Makes it easier for us Java developers.
For sure.
We can just map our Java entities directly to those database tables. So persistence becomes like a natural part of my object-oriented design.
That's exactly right.
Instead of thinking in terms of tables and columns all the time.
Yeah, you're thinking in terms of objects.
Right. That's how our brains work.
Exactly. And it just makes the development process so much more intuitive.
It seems like this would make my code like way more readable and maintainable.
Absolutely. You're not juggling all those SQL queries and result sets anymore. You're just working with the Java objects and their properties. So it simplifies things.
Much cleaner.
And it makes your code more robust and less prone to errors.
Yeah, less bugs.
Exactly.
Okay, so we've got the blueprint with JPA. But now let's meet the contractor. Hibernate.
All right, let's talk about Hibernate.
It's like the most popular JPA implementation out there, right?
Yeah, by far.
And it's known for being really powerful and flexible.
Yes, it's amazing what you can do with Hibernate.
So tell me a little bit about what makes Hibernate so special?
Well, one thing that's really impressive is its architecture.
Okay.
It's very well designed. It handles everything from mapping those objects to managing your database connections.
Oh, wow.
And it's got tons of advanced features.
Okay, let's break this down a bit. First, we've got those persistent objects, which are basically our regular Java objects, but with some Hibernate magic sprinkled on top.
Right, exactly. These are the objects that Hibernate will map to your database tables.
Okay.
So you can store them and retrieve them easily.
And how does it handle that mapping? Like, how does it know which object goes with which table?
Well, there are a couple of ways. You can use XML configuration files, which were more common in the past.
Okay.
But these days, most people use annotations.
Yeah, I like annotations. They keep everything nice and tidy.
They do, yeah.
Right in the code.
Exactly. It's all right there in your Java code.
So I can just, like, specify which table an object maps to?
Yep, exactly. And you can specify which properties correspond to which columns in the table.
Nice.
And even how those properties should be handled during persistence.
Cool. And then there's the configuration layer, where we tell Hibernate how to connect to the database and stuff, right?
Yes, exactly. That's where you provide all the essential details that Hibernate needs to manage your data.
Okay, so it's like setting up the connection string and all that.
Yeah, that's part of it.
All right. And then there's this thing called the session factory, right?
Yes, that's an important part of Hibernate.
So what is that all about?
Well, you can think of the session factory as, like, the director of the show, you know?
Okay.
It's responsible for creating those all-important session objects.
Okay, so the session factory is like a factory that produces session objects.
Exactly.
And the session objects are like the workers that actually go and interact with the database.
That's a great way to think about it.
All right, so I make my requests through the session, and it takes care of all those low-level database details.
Yep, that's exactly how it works.
And the session factory, it's designed to be, what's the word, thread safe.
Yeah,
right?
that's an important feature.
So multiple threads in my application can use the same session factory without messing things up.
Exactly. It ensures that all those database interactions are well coordinated.
Okay, so no data corruption or inconsistencies.
Exactly. It prevents all of that.
That's a good thing. It is. All right, so we've got the mapping handled, the configuration set, and the session factory ready to go. Now, let's talk about how we actually use those session objects to do stuff like create, read, update, and delete data.
All right, the CRUD operations.
Right, exactly, the CRUD operations.
That's where Hibernate really shines.
Okay, tell me about that.
Well, it gives you a very elegant and intuitive way to perform those operations.
No way?
Using the session interface, which has all these methods that directly correspond to those actions.
So there's like a method for creating a new record.
Yeah, you've got the persist method or the save method.
Okay.
And you've got merge or update for modifying existing ones.
So instead of writing raw SQL queries for every single CRUD operation, I can just use these session methods.
Exactly. It's much simpler.
And Hibernate just handles the translation to the appropriate SQL commands behind the scenes.
That's exactly right.
Cool. So it's like saving me a ton of time and effort.
It is, and it makes your code much cleaner and easier to understand.
Okay, so Hibernate maps my objects, manages those database connections, and makes CRUD operations a breeze.
Yep, it handles all of that.
But I'm curious about something.
Okay.
What if I need to retrieve specific data from the database based on some criteria? You know, like maybe I need to find all the customers who live in a certain city.
Right.
How does Hibernate handle that?
That's where Hibernate Query Language comes in, or HQL for short.
HQL, okay.
And here's the really cool part. HQL is not your typical database query language. It's completely object-oriented.
Oh, so instead of writing queries in terms of tables and columns, I can write them in terms of my Java entities and properties.
That's exactly right. You got it.
So it's like I'm querying the database as if it were just a collection of Java objects.
Exactly.
That sounds way more intuitive for a Java developer.
Oh, absolutely. You can leverage all your existing knowledge of Java and your object model to retrieve data from the database.
So I can use like Java syntax and concepts?
Yeah, like classes, properties, comparisons.
To build my queries.
It makes it much more readable and maintainable than traditional SQL.
And probably less error prone too, right?
Oh, definitely. You're less likely to make mistakes.
So this HQL sounds incredibly powerful.
It is.
I'm already feeling like we've just scratched the surface of Hibernate.
Oh yeah, we've got a lot more to cover.
There's so much more to explore, especially with HQL.
Definitely.
It's amazing to think I could be querying my database using the same object-oriented concepts I use every day in Java.
It's a game changer.
It really is.
It really simplifies the whole development process.
So much easier.
So much easier.
All right, let's take a break here.
Okay.
And we'll come back and dive deeper into HQL in part 2.
Sounds good.
We'll explore some of those advanced Hibernate features.
We'll uncover some hidden gems along the way.
I like it.
It'll be fun.
Stay tuned.
I can't wait.
Welcome back. I'm ready to jump back into Hibernate.
Okay, let's do it.
We've got a good foundation now.
Yeah.
But I know there's so much more to learn, especially with this HQL stuff.
For sure.
It's just amazing to think I could be querying my database using the same concepts I use every day in Java.
Right. That's one of the things that makes Hibernate so appealing to Java developers.
Totally.
You don't have to switch between two different mindsets.
Right, like object-oriented programming versus relational databases.
Exactly.
So you mentioned that with HQL, we write queries in terms of our Java entities and properties.
Yeah.
Can you give me an example of how that works, like a real-world example?
Sure. Let's say you have a customer entity
Okay.
with properties like first name, last name, email. If you wanted to find all the customers with the last name Smith using regular SQL, you'd write a query like select from customers where last name is Smith.
Okay, yeah, that's familiar.
But with HQL, you just write from customer where last name is Smith.
Oh, wow, that's so much cleaner.
Right. It's so much easier to read.
Yeah, it looks almost like a regular Java statement.
Exactly.
So much more natural.
And the cool thing is, HQL isn't limited to just simple queries like that. You can use it for all sorts of complex logic, just like you can with SQL.
Oh, so I can still use where clauses for filtering and order by why for sorting.
Absolutely. You can even do aggregations.
Like what?
You know, like counting or averaging values using functions like count and sysimim.
Okay, so it's pretty much as powerful as SQL, but I can use my familiar Java syntax.
Yeah, that's the beauty of it.
Really nice.
It makes your code so much more readable and maintainable.
Yeah, I can see that.
And there's another big advantage of HQL that's often overlooked.
What's that?
Database independence.
Okay, what does that mean?
So because HQL works with your Java entities, your queries aren't tied to a specific database.
Oh, that's interesting.
So like if you switch from MySQL to PostgreSQL, your HQL queries will still work.
Without having to change them.
In most cases, yeah.
That's amazing.
Hibernate just handles the translation for you.
So it figures out the right SQL dialect for whatever database I'm using.
Exactly.
That's super powerful.
It really is.
Saves a ton of time and effort.
For sure.
Okay, so HQL hits that sweet spot between being expressive and being portable.
Yeah, I think that's a good way to put it.
But before we go too deep into HQL,
Okay.
let's go back to those CRU'd operations for a minute.
Right.
How does all this HQL stuff fit into the bigger picture? Like, how do we actually work with data in Hibernate?
Okay, well, remember those session objects we talked about?
Yeah, those are important, right?
They are. They're at the heart of Hibernate's data management.
Okay.
Think of a session as a conversation with your database.
Okay.
Where you load objects, modify them, create new ones, and ultimately decide what changes you want to save.
So it's like the middleman between my Java code and the database.
Exactly.
I make my request through the session, and it takes care of the rest.
That's it.
All right. And you mentioned something about object states earlier.
Yes. That's a key concept to understand.
Tell me more about that.
So Hibernate keeps track of whether an object is new,
Okay.
or if it's been modified, or if it's been deleted. And it uses that information to figure out what SQL commands to execute.
So can you walk me through an example of that?
Sure. Let's say you want to create a new customer record.
Okay.
First, you create a new instance of your customer entity
Got it.
and set its properties like name, email, all that.
Mm-hmm.
Then you call the persist method on the session.
Okay, passing in my customer object.
Exactly.
Something like session.persist.
That's it. And here's the thing.
Yeah.
Hibernate doesn't immediately run off and insert that into the database.
Oh, really?
It just marks the customer object as persistent,
Okay.
meaning it's being tracked by the session.
Gotcha.
But the actual database insert might happen later.
So it's like it's waiting for the right moment.
Exactly. This delayed approach is what makes Hibernate so efficient.
Okay, so it avoids unnecessary trips to the database.
Right, and it can batch multiple operations together.
Which is good for performance.
It's especially helpful when you're making a lot of changes.
Yeah, that makes sense.
So it's all about optimizing those interactions.
So what about retrieving an object from the database?
To do that, you use the get or load methods on the session.
And those let me retrieve an object by its primary key, right?
Exactly.
So if I know the customer ID, I can just fetch that customer object directly.
That's it.
And what's the difference between get and load?
It's a subtle difference.
Okay.
Get will return null if the object doesn't exist, while load will throw an exception.
Okay, so I have to be careful which one I use.
Yeah, you want to choose the right method for the situation?
So if I'm certain the object exists, I can use load.
Right.
But if I'm not sure, I should use get to avoid errors.
Exactly. Good thinking.
And once I have the object, I can modify its properties.
Absolutely, just like any other Java object.
And Hibernate keeps track of those changes.
Yes, it's always watching.
So when I'm ready to save them, I just call the update method.
You got it.
And if I want to delete an object, there's a delete method.
Exactly. It's all very straightforward.
This is so intuitive.
All right.
Hibernate streamlines the whole process of working with data.
It makes it so much easier.
But there's one thing I'm still a little fuzzy on.
Okay, what's that?
Transactions.
Ah, yes, transactions.
I know they're important for keeping my data safe.
They are essential for data integrity.
But I'm not quite sure how they fit in with Hibernate.
All right, well, imagine you're transferring money between two bank accounts.
Oh.
You want to make sure both operations, the debit and the credit, happen successfully.
Right. Otherwise, you might lose money.
Exactly. And if one of them fails, the whole thing needs to be canceled.
To prevent any inconsistencies.
Precisely. That's what transactions are all about.
So how does Hibernate help us manage those transactions?
There are a couple of ways.
Okay.
You can use programmatic transaction demarcation.
What does that mean?
It means you explicitly start and end the transaction in your code.
Okay.
Using the transaction interface that Hibernate provides.
So I can wrap a series of operations within a transaction.
Yeah, to make sure they all succeed or fail together.
That's what we want.
Exactly. It's all or nothing.
And you mentioned another way to handle transactions.
Yeah, declarative transaction management.
Okay, that sounds a little less hands-on.
It is. You use annotations or XML configuration to tell Hibernate which methods should be part of a transaction.
Oh, so it takes care of the starting and committing for me.
Exactly. It simplifies your code a lot.
And reduces the risk of errors.
That's right. You're less likely to forget to commit or roll back.
That's a good thing.
Definitely.
So this declarative approach seems much easier to manage.
It is, especially for larger applications.
But with all this automation going on,
Yeah.
is there a chance that Hibernate might be hiding some of the complexities of database operations from me?
That's a good question.
Like, should I still be worried about things like SQL injection or performance bottlenecks?
You should always be aware of those things.
Okay, so I shouldn't just assume Hibernate will handle everything perfectly.
Exactly. It's a powerful tool, but it's not a magic bullet.
Gotcha.
You still need to understand the fundamentals of how databases work.
Yeah, like how to write efficient queries.
Right, and how to design your data model effectively.
Okay, so it's a balance between using Hibernate's power and still knowing what's going on under the hood.
That's a good way to think about it.
And what about security, like SQL injection?
Hibernate does have safeguards in place to prevent that.
Oh, good.
For example, when you use HQL or the Criteria API, it automatically parameterizes your queries.
Okay, and that prevents SQL injection attacks.
Exactly. It's a common security best practice.
That's reassuring to know.
It is, but it's always a good idea to stay informed.
Yeah, about security best practices.
And keep your Hibernate version up to date.
That makes sense.
To make sure you have the latest security enhancements.
This is all incredibly helpful.
I'm glad you're finding it useful.
I feel much more confident in my understanding of Hibernate now.
That's great to hear.
And how it can simplify my Java development.
It can really make a big difference.
And we're not even done yet.
Nope, we've got one more part to go.
In the final part of our deep dive, we'll explore some of the even more advanced features of Hibernate.
Like lazy loading, caching, and relationships.
Oh, yeah. Those sound interesting.
They are. They can really take your Hibernate skills to the next level.
I can't wait. I'm eager to see what else Hibernate can do.
It's going to be good. We'll uncover all the secrets.
Welcome back to our deep dive on Hibernate. I'm really excited to explore some of those advanced features we talked about.
Yeah, me too.
Like lazy loading and caching.
Okay.
We've seen how Hibernate simplifies those basic database interactions.
Right.
But what about those more complex scenarios?
Yeah, that's where things get really interesting.
What does Hibernate offer for those situations?
Well, it's got a ton of features
Okay.
that go way beyond the basics.
Okay.
You can fine-tune performance, manage relationships between entities, optimize data access.
All right, let's start with lazy loading. I've heard that term before.
Yeah, it's a popular one.
But I'm not totally clear on how it works or why it's so beneficial.
So lazy loading is a technique Hibernate uses to defer loading of related entities until they're actually needed.
Oh, okay.
So imagine you have a customer entity
Yeah.
that has a bunch of order entities associated with it.
Right. One customer can have multiple orders.
Exactly.
Okay.
Without lazy loading, every time you fetch a customer, Hibernate would load all its related orders too.
Okay, so it would just grab everything all at once.
Yeah, eagerly.
But what if I don't need all that order information right away?
That's the problem, right? You might end up loading a ton of data you don't even need.
And that would slow things down.
Exactly. It can be a big performance hit.
Okay, so lazy loading prevents that.
Yes, it allows you to avoid that overhead by only loading the order objects when you actually access them.
Oh, I see.
So if you just fetch a customer,
Mm-hmm.
but you don't touch its orders,
Yeah.
those order objects won't even be loaded from the database.
That's pretty smart.
It is. It's all about efficiency.
Okay, so it only loads what I need when I need it.
Exactly.
But how does Hibernate know when to actually load those related entities?
It uses proxies.
Proxies.
Yeah, they're like placeholder objects
Okay.
that represent the related entities.
So when I first fetch a customer,
Right.
its order collection actually contains a proxy object.
Yes, and that proxy just sits there
Okay.
until you actually try to access the order.
It's like if I loop through the orders or something.
Exactly. Then Hibernate will trigger a query to load the real order objects.
Oh, I see. So it's like a just-in-time loading
Oh,
mechanism.
a good way to put it.
It only goes and gets the data when it absolutely has to.
Exactly.
This lazy loading seems like it could be a huge performance boost.
It can be, especially for applications with complex object graphs.
Right. There are lots of relationships between entities.
Yeah, you don't want to load the entire database every time.
Exactly.
Lazy loading helps you keep things lean and efficient.
So we've got lazy loading for optimizing data fetching.
Mm-hmm.
Now, what about caching?
Caching is another area where Hibernate excels.
Okay, tell me about that.
It has a multi-layered caching system
Okay.
that lets you control how data is cached and retrieved.
So it's not just like a simple on or off switch.
No, you have a lot of control.
Okay, so what are the different layers?
The main ones are first-level cache and second-level cache.
Okay,
First-level cache is enabled by default.
gotcha.
It's associated with the session object.
Okay.
It acts as a temporary store for objects that have been loaded or modified within that session.
So if I fetch the same object multiple times within the same session,
Right.
Hibernate will just grab it from the first level cache.
Exactly. It doesn't have to go back to the database.
That makes sense.
It can really save you a lot of database hits.
And what about second level cache?
Second-level cache is more global.
Right.
It's shared across multiple sessions.
Oh, so even if I close a session and open a new one, I can still benefit from the data in the second level cache.
Exactly. It's more persistent.
Okay.
You can configure it to store data in memory or on disk.
So it's good for data that doesn't change very often.
Yeah, like reference data or lookup tables.
Makes sense.
Caching is all about making your application faster and more responsive.
This is powerful stuff.
It is.
Hibernate really gives you all the tools you need
It's very comprehensive.
to optimize data access and performance.
Yeah, you can fine-tune it to meet the needs of your application.
Okay, we've covered lazy loading and caching.
Mm-hmm.
Now, what about relationships between entities?
Oh, yeah, that's another important aspect.
Most real-world applications have data that's connected in different ways.
Right, it's not just isolated objects.
So how does Hibernate deal with that?
Well, it has a bunch of features for mapping and managing relationships.
Okay.
You can model one-to-one, one-to-many, many-to-many.
So all the common types of relationships.
Exactly.
And I could define these relationships in a way that reflects my actual data model. Yes, you're in control.
And Hibernate takes care of enforcing those relationships at the database level.
That's right. Make sure everything stays consistent.
Like if I have a one-to-many between customer and order,
Yeah,
Hibernate will create the foreign key constraints and all that.
exactly. It handles all the database details.
That's great. I don't want to have to worry about that stuff manually.
You don't have to.
And when I fetch an entity that has relationships,
Mhm.
I can control how those related entities are loaded.
Yes, you can use lazy loading or eager fetching.
So I can choose the best approach for each situation.
Right. You have a lot of flexibility.
Wow, this has been an amazing journey.
I'm glad you've enjoyed it.
We've covered so much ground,
Yeah.
from the basic concepts of ORM and JPA,
Mhm.
all the way to these advanced features like lazy loading, caching, relationships.
It's a lot to take in.
It is, but I feel so much more confident in my Hibernate skills now.
That's great to hear.
And I think our listeners will too.
I hope so. This deep dive has been incredibly insightful and empowering.
I agree.
Hibernate is a powerful tool,
It is, and it's only getting better.
and it can really simplify Java development.
It can make a big difference in how you build applications.
So a huge thank you to our listener for submitting this topic.
Yeah, great topic.
And thank you to you for being such a fantastic guide.
It's been my pleasure.
To our listeners, I hope you found this deep dive as informative and engaging as I did.
Keep learning and keep building amazing things.
That's right. There's always more to explore in the world of Java.
Absolutely.
So keep those questions coming,
We love to dive deep.
and we'll see you in the next episode.
Until next time.